Today we have absolute value bars, but we have them isolated on both sides. That's important. If you ever have two different absolute value bars, let's say it says absolute value of 3x minus 4 times the absolute value of x, you would move the absolute value of x to the other side, or plus the absolute value of x. Sometimes you'll have to move it. But what we do here is we still split it. So when we split it, it looks like this. It's going to say 3x minus 4. That does not change. And then we're going to say it's equal to negative x. And then the other side is going to be 3x minus 4 equal to positive x. Okay, so when we have 3x minus 4 equals negative x, 3x minus 4 equals positive x, now what we do is we solve for x on both sides. Again, since the variable's already by itself on the right side, I'm going to move my 3x to the right. So I'm going to subtract this 3x to the other side. And that gives me on the left-hand side negative 4 equals negative 4x. And then I divide both sides by negative 4. And I get one answer at x equals positive 1. Then if I do that same work on the other side, I'm going to still subtract 3x. And I get positive x minus 3x is negative 4 is equal to negative 2x. I divide both sides by negative 2. And I get 2 is equal to x. So those are your two solutions, there and there. Again, the only difference is from this one, from yesterday, is that we only change the sign of what's on the right, not on the left. So whatever's inside the bar still doesn't change, just the one on the right-hand side. That's interesting. Next page. We need to split. When we split it, here's what it looks like. We have x plus 8 is equal to, when we make one side negative, you're going to change the sign of every term that's inside the absolute value bars. So since that 2x is positive, I'm going to make it negative. Since that 1 is positive, I'm going to make it negative. But when I do the other side of this split, I'm going to say x plus 8 is equal to 2x plus 1. I'm going to leave it exactly the same. Okay, so basically what I did on the left is I distributed a negative through that side. Just the right side though. Okay, did you guys see that? Yeah. I'll add 2x to both sides. And I'll get 3x plus 8 equals negative 1. I'll subtract the 8. I'll get 3x equals negative 9. I'll divide by 3. And one of my solutions is x equals negative 3. For the other side, I subtract the 2x. I get negative x plus 8 equals 1. I minus the 8 from both sides. Not divide, minus, sorry. So let's see, 1 minus 8, I get negative x is equal to negative 7. So what do? Those are my two answers. 2. Okay, so I'm going to add these up, 10 plus negative 6, and then I'm going to divide by 2, and I get 4 over 2, which is 2. This right here, what this gives me is my number in the middle. So in your assignment, it tells you to write an absolute value equation. So you're going to start with this, x minus 2. Now if this 2 would have been, if that 2 would have been positive, we would have, or excuse me, if that 2 would have been negative, we would put x plus 2. Okay, we want to get that number to 0. We want it, whatever number I plug in for x, I want it to equal 0. Does that make sense? Okay, because I'm finding a distance from 0, so it's going to be x minus 2. Then to find the number that goes on the outside, what I need to do is I need to find the distance between my number in the middle and either one of these other two. So it doesn't matter which one you do. You need to either do 10 minus 2 or you need to do negative 6 minus 2. Because either way, how far is that number from 2? 8. So your other number is 8. And that's how you write an absolute value equation, right there. This one's kind of tricky because can we isolate our absolute value bar on the right? Can't really isolate it. We can't divide that 2 because all that's going to do is send that 2 to the other side. So here's what we do. We go ahead and we split it into two problems. But here's how this works. The 4x minus 10 we're going to leave the same. Okay? When we say equals on the left side, the 2 needs to be outside the parentheses. But what do we need that 3x plus 1 to be?
Negative.
Negative on the left side. So what I need to do is I need to distribute a negative through, so that 3x plus 1 on the left side is now going to be negative 3x minus 1. And that's just because I distributed a negative. On the right side, though, it's going to be okay to leave it the same. So it's going to be 4x minus 10 is equal to 2 times the quantity, 3x plus 1. This one up, we have 4x minus 10 is equal to 2 times negative 3 is negative 6x. 2 times negative 1 is negative 2. I go ahead and finish this. I'm going to add 6x to both sides. So I get 10x minus 10 is equal to negative 2. I add 10. So I get 10x is equal to 8. Then I divide by 10. I'll have to scroll down here. I have to divide by 10. Well, that did not pan out like I wanted it to. Weird. Okay, so I divide by 10. And then I just reduce that. So x is equal to, what is 8 over 10 reduced to? Do we know? 4x minus 10 equals 2 times 3 is 6x. 2 times 1 is plus 2. I subtract the 6x this time. So I have negative 2x minus 10 is equal to 2. I add the 10 this time. I get negative 2x is equal to 12. Okay, I divide by negative 2. And I get x is equal to negative 6. Okay, fraction answers will happen there. I have a problem that looks like this. Again, absolute value bars are isolated on the left-hand side. I split. I get 2x plus 12 equals negative 4x. And then I get 2x plus 12 equals positive 4x.
And then I turned my 5 and I realized why do I have to show it? I'm smart. Before I was like 13. And after that,
Which is our number 7.
1.4 day 2.